In 1883, between the islands of Java and Sumatra, a green volcanic island sat in one of the busiest waterways of the Dutch East Indies. From a distance, Krakatoa looked almost peaceful. The Sunda Strait shimmered under equatorial light. Blue water moved around forested slopes. Ships passed through the channel with cargo, maps, and logbooks full of ordinary observations. To the sailors who crossed those waters, the island was a landmark. To local fishermen, it was part of a seascape they had read for generations. Currents, wind, clouds, the colour of the water. These were signs people understood. Trade had moved through this passage for centuries. Empires had mapped it. Captains had trusted it. Men on the decks of colonial vessels could look toward Krakatoa and see only another tropical silhouette rising from the sea. But Krakatoa was carrying a different kind of message. Above the surface, the island seemed alive with birds, trees, and tropical heat. Beneath it, pressure was gathering in silence. Rock was shifting. Gas was building. Magma was forcing its way upward through an old volcanic system that had waited far longer than any human memory. Nothing about the island looked ready to change the world. Its violence seemed buried in the past, folded into rock, hidden beneath green slopes and ordinary mornings. The human world around it had become confident in its own routines. That was the danger. In May of 1883, the first warnings became visible. Steam and ash began rising from one of Krakatoa's cones, high enough for passing vessels to see from miles away. At first, the sight did not seem like the beginning of a catastrophe. Volcanoes smoke, islands rumble. In a region shaped by fire, unrest could be noticed without being feared. Reports reached Batavia, the colonial centre across the water. But the response remained cautious, almost calm. There were observations. There were notes. There were brief mentions in the press. There was no full evacuation of the exposed coasts. No one yet understood that the island was not simply venting. It was preparing. Fine ash settled on ships moving through the strait, dusting ropes, canvas, and deck planks in a pale grey film. Sailors reported the smell of sulphur over the water. The air felt heavy, electrically charged, as if the sky itself had become part of the volcano. Some crews described strange disturbances around their instruments, the kind of details that could be written down and still not understood. The warning existed, but it arrived in fragments. A smell on the wind, a stain on a deck, a dark column above a green island, a note sent back to an office where commerce still moved on schedule. And because each sign arrived alone, each sign could be made smaller. By July, Krakatoa grew louder. Ash and steam climbed higher into the tropical sky. Explosions rolled across the water at night, deep enough to unsettle the coastal communities of Java and Sumatra. For people along those shores, the island was no longer just a distant shape. It had become a sound in the dark. Ships were advised to keep their distance. Traffic through the strait slowed, but it did not stop. The sea lanes were too important. The routine of empire, trade and travel was not easily interrupted by a mountain that had not yet revealed its full intent. Then, in August, a Dutch government surveyor reached the island. What he found was no longer the same Krakatoa sailors had known. The forests that once covered the slopes were gone. In their place lay fields of ash, hot ground, and black volcanic rock. The soil had warmed. 3 active vents were releasing huge quantities of ash into the air. Around the island, the sea itself appeared disturbed, coloured by chemicals and heat rising from below. It was as if the island had been stripped of its mask. The surveyor recommended that ships avoid the area entirely. Authorities began to pay closer attention. Scientists and engineers debated what the activity meant and whether the volcano could truly threaten the populated coastlines beyond the strait. But debate is not the same as protection. A danger can be studied and still not be escaped. A warning can be recorded and still fail to reach the people who need it most. The mountain did not wait for certainty. It did not wait for a final report. It did not wait for people to agree on the scale of the danger. By the final days of August, the question had changed. It was no longer whether Krakatoa would erupt. It was how much of the world would hear it when it did. On the morning of August 26, 1883, Krakatoa stopped being a distant warning. It became an event. A detonation rolled out from the island with enough force to rattle windows in Batavia, roughly 100 miles away. For people in the city, the sound was not yet the full catastrophe. It was only the first hard strike of something much larger moving toward them. In the Sunda Strait, ships found themselves inside a world that was changing by the hour. The sea grew restless. The air felt charged. Ash thickened above the water until daylight began to fail. By early afternoon, the sky was darkening in a way no ordinary storm could explain. Then the sun disappeared. The steamship Loudon, carrying passengers through the strait, moved through a darkness so complete that afternoon no longer felt like afternoon. Pumice and ash fell from the sky. The decks had to be cleared again and again. Every surface became a place where the volcano could gather weight. There was no radio signal to call for help, no live warning from the coast, no voice from Batavia explaining what was happening. Each ship was alone inside the eruption, surrounded by black air, falling stone, and a sea that no longer behaved like the sea people knew. The world had narrowed to the ship, the ash, the instruments, and the sound of the volcano tearing itself open. As night came, the darkness did not soften. It deepened. Volcanic lightning flashed through the ash cloud, sudden and violent, illuminating the sky for seconds at a time before dropping everything back into blackness. The storm above Krakatoa was not weather in the ordinary sense. It was the atmosphere reacting to a mountain being ripped apart from within. By evening, the Sunda Strait was no longer a shipping lane. It was an arena. Water, fire, air, and stone had become part of the same disaster. The people caught inside it could not see the whole event. No one could. They could only feel pieces of it arriving through sound, pressure, ash, and fear. And still, the worst had not happened. Before dawn on August 27th, the volcano entered its final and most violent phase. At about 5:30 in the morning, a major explosion tore through the island. Then another followed. The sky over Java and Sumatra filled with ash and gas rising into the upper atmosphere. Dawn came, but it did not bring light. It revealed a world under a ceiling of iron-grey darkness. The air was full of fine ash, falling like dead snow over the water. Then, shortly after 10 in the morning, Krakatoa produced the detonation that would carry its name into history. The third great explosion was not simply loud. It was planetary. The sound travelled across oceans and continents. It was heard thousands of miles away, in places so distant that listeners mistook it for cannon fire. In the Indian Ocean, on remote islands far beyond the horizon, people heard the voice of a volcano they could not see. Near the Sunda Strait, the blast was not only heard, it was felt. The pressure wave moved outward from Krakatoa in all directions, compressing the air itself into a pulse large enough for instruments around the world to record. Barometers rose and fell as the wave passed from city to city, crossing oceans, continents, and hemispheres. One island had spoken. The whole planet had answered. The wave circled the Earth again and again, returning like an echo from the far side of the globe. In observatories and weather stations, thousands of miles apart, the same invisible shock appeared on paper as a line, a spike, a disturbance. For science, it was evidence. For those near the volcano, it was the sound of the world breaking open. And yet the sound was only part of the catastrophe. Beneath the explosions, something even more destructive was beginning. The island's interior had been emptied. Its structure had been weakened. The land that had risen above the Sunda Strait for generations was now approaching collapse. Krakatoa had not only erupted, it was about to disappear. What followed the final detonation was not silence. It was collapse. Deep beneath Krakatoa, the magma chamber had been emptied with catastrophic speed. The mountain had lost the support that had held it above the Sunda Strait. For centuries, the island had stood as land. Forests had grown over it. Birds had nested there. Ships had used it as a point of reference. Now the foundation was gone. The island began to fail from within. 2/3 of Krakatoa collapsed beneath the sea, taking with it an entire volcanic landscape that had once risen above the water. Where solid ground had stood, the ocean rushed into a new volcanic basin. The map of the Sunda Strait had changed in a single morning. This was not only an eruption, it was the disappearance of a mountain. Millions upon millions of tons of rock, ash and pumice had been thrown into the sky or swallowed by the sea. The surface of the earth had been rearranged so violently that charts, coastlines and human memory no longer matched the world in front of them. But the ocean did not simply fill the empty space. It answered. The collapse displaced an enormous mass of water. The sea pulled back, gathered itself, and then returned with a force no coastal village could withstand. What rose out of the Sunda Strait was not a normal wave. It was a moving wall of ocean, tens of meters high in places, carrying the energy of the volcano outward toward Java and Sumatra. For the people on the coast, there was no warning system, no radio broadcast, no siren, no time to understand what the retreating sea meant. Survivors on higher ground watched the water draw away from shore, exposing land that should have remained hidden beneath the tide. For a few moments, the coastline seemed to open. Then the horizon changed. The water came back. It came not as surf, but as a moving cliff. A dark mass of sea advanced inland, carrying wreckage, boats, trees, and the broken remains of the shoreline with it. The towns of Merak and Anya on the Javanese coast were struck with devastating speed. Across the strait, Teluk Betung on Sumatra faced the same force, as water surged beyond the boundaries people had believed were safe. The sea crossed those boundaries as if they had never existed. Homes were torn away. Roads vanished. Harbours became fields of debris. Coastal settlements that had lived by the water for generations were suddenly destroyed by the same water that had sustained them. At Anya, the lighthouse built to guide ships through the strait disappeared in the surge. A structure meant to make the sea safer was taken by the sea itself. On Sumatra, colonial records describe the Dutch naval vessel Beru being carried far inland, driven up a river valley by the force of the tsunami. The image is almost impossible to hold in the mind. A ship built for water left stranded where water should not have been. That was the scale of the morning. The tsunami did not strike one village and stop. It moved through the strait, wrapping the coasts of Java and Sumatra in destruction. Settlement after settlement was damaged or erased. Places that had names, routines, markets, families, and histories were reduced to scattered remains before the people beyond the coastline could even understand what had happened. Then came the quiet after the water. Not peace, only absence. The kind of silence that follows when the sound of a living place has been taken away. Only after that silence could the numbers begin. And the numbers were unbearable. Roughly 36,000 people died in the disaster, most of them taken not by ash or fire, but by the tsunamis created when Krakatoa collapsed into the sea. The volcano had destroyed itself. The ocean had carried that destruction to the people, and the waves did not remain local. They crossed the Indian Ocean and were recorded far from Indonesia. Tide gauges and instruments picked up their passage across distant coasts. The disturbance moved outward through the world's oceans, fading with distance, but never immediately disappearing. That is what made Krakatoa different. It was not only a local catastrophe, it was a planetary signal. The explosion moved through the air. The tsunami moved through the sea. The ash moved through the sky. In a single sequence of hours, one island had touched the atmosphere, the oceans, the climate, and the future of science. But for the survivors along Java and Sumatra, the meaning was much simpler. The world they had known at sunrise was gone. By the end of August 27th, Krakatoa was no longer the island people remembered. The coasts facing it were no longer the same coasts. Families, settlements, ships, and landmarks had been taken into a disaster that began beneath a mountain and ended in the lives of ordinary people. The tragedy was not only that the volcano erupted, it was that the warning had existed. The danger had grown in plain sight, and still the full scale of it arrived beyond human imagination. The sea had returned, and it had returned as history. Krakatoa did not end when the waves withdrew. The island had collapsed. The coasts had been shattered. The sound had crossed oceans. But above the wreckage, another part of the disaster was only beginning. It was rising into the sky. During the eruption, ash and volcanic material were blasted tens of miles upward, high enough to enter the upper atmosphere. This was not the kind of ash that simply falls back to Earth after a storm and disappears with the next rain. The finest particles stayed aloft. Sulfur gases reacted with water vapor and formed tiny aerosols, suspended far above ordinary weather. From there, Krakatoa began to travel without moving. The volcano had destroyed itself in the Sunda Strait, but its atmosphere had no borders. High-altitude winds carried the veil outward from the tropics. Day by day, week by week, the particles spread around the planet, thin enough to be invisible in ordinary daylight, powerful enough to change the way sunlight reached the Earth. The disaster became global in a new form, not as a wave, not as a sound, but as a dimming. Sunlight entered the atmosphere and met a volcanic veil. Some of it scattered. Some of it reflected back towards space. Across the year that followed, global temperatures fell by about 0.5 degrees Celsius, and weather records showed disturbances far beyond Indonesia. The planet had been touched by a single eruption, and the atmosphere carried the evidence everywhere. For many people, the first sign was not scientific. It was visual. The sky changed. Evening after evening, far from Java and Sumatra, people looked west and saw colours that seemed almost impossible. Sunsets burned deep red, violet, orange and copper long after the sun had dropped below the horizon. The glow did not fade quickly. It lingered, stretched across the sky, and left entire cities staring upward in silence. These were not ordinary sunsets. They were the after-image of Krakatoa. In Europe, in North America, in Asia, in Australia, observers recorded skies unlike anything they had seen before. Artists sketched them. Writers described them. Scientists measured them. Ordinary families stepped outside at dusk and watched the horizon burn with colour, not knowing that the light above them had begun as ash over a ruined island thousands of miles away. In some places, the glow was so intense that people mistook it for fire. The horizon looked as if a city were burning beyond view. Fire engines were reportedly called out in parts of the northeastern United States, when residents believed the red sky meant a distant blaze. but there was no fire to fight. Only sunlight, broken and scattered by the remains of Krakatoa. That was the strange cruelty of the phenomenon. The same eruption that had drowned coastlines and erased villages also painted the world's skies with breathtaking beauty. People who had never heard the explosion, who had never seen the tsunami, who had never stood on the shores of the Sunda Strait, still lived under its colours. The catastrophe had become beautiful at a distance, and that beauty carried grief inside it. In London, observers filled notebooks with descriptions of the unusual light. Across the scientific world, reports arrived from different continents describing the same strange atmospheric displays. The sky itself had become a global record, written in red and violet above cities that had never shared the same disaster before. Later, some would connect the blood-red skies of this period to the visual memory behind Edvard Munch's famous image of a terrified figure beneath a burning sky. Whether that connection explains the painting completely remains debated. But the idea endures for a reason. Krakatoa had placed a wounded colour into the world's atmosphere, and people remembered it. For science, the eruption offered something extraordinary. A natural experiment on a planetary scale. By the 1880s, meteorological stations, barometers, observatories, and scientific societies were spread widely enough to capture the same event from many corners of the world. The eruption had produced sound waves, pressure waves, ocean waves, temperature changes, and optical displays. Each one could be observed. Each one could be compared. Each one could become data. For the first time, scientists could follow a volcanic disaster not only where it happened, but across the entire Earth system. The atmosphere was no longer just the air above one country. It was a connected machine. A disturbance in the tropics could change skies in London, sunsets in New England, temperatures in Europe, and scientific records in observatories across the globe. Krakatoa forced the world to understand that the planet was not divided into separate local events. Air moved, oceans carried energy, light scattered, climate responded. The eruption had taken tens of thousands of lives near the Sunda Strait, but it also left a second legacy in the sky. It taught humanity that a volcano could reach beyond its island, beyond its ocean, beyond its century. It could enter the atmosphere and write itself across the planet in colour, cold, and fear. For months, the sunsets kept returning. Each evening glow was beautiful, and each one was a reminder that beauty sometimes is the far edge of a catastrophe. Krakatoa entered the world in more than one way. It moved through the atmosphere as dust. It moved through the ocean as waves. It moved through instruments as pressure. And then, almost instantly, by the standards of the 19th century, it moved through wires. By 1883, the world was no longer connected only by ships, letters, and travellers returning from distant ports. Undersea telegraph cables had begun to stitch the major empires and trading centres together. Messages could cross oceans with a speed that would have seemed impossible only decades earlier. Batavia was connected to Singapore. Singapore connected onward to India, the Red Sea, the Mediterranean, and Europe. So when Krakatoa erupted, the news did not have to wait for a ship to complete a voyage. It travelled as an electrical signal through cables beneath the sea. A disaster born from deep inside the earth entered the nervous system of the modern world. Within hours, reports began moving outward. Brief, urgent, incomplete, but fast. Editors in Europe received fragments of the catastrophe before anyone fully understood its scale. Newspapers began printing accounts from a place most readers would never see, describing a volcano that had destroyed itself, waves that had erased coastlines, and sounds heard across impossible distances. For earlier eruptions, the world had learned slowly. Tambora in 1815 and Laki in 1783 had altered climate and human life, but news of them moved through the old rhythms of empire: ships, letters, rumours, official reports, and delayed testimony. Krakatoa belonged to a different age. It was still a natural disaster, ancient in force, but it was carried into public consciousness by modern technology. That made it feel new. A volcano had erupted in the Sunda Strait, but the shock belonged to the world. For readers in London, New York, Calcutta, and beyond, Krakatoa became more than a distant island. It became a name printed again and again, attached to darkness, waves, red skies, and a sound so vast it seemed to exceed human language. People who had never heard of the island before now knew it as a symbol of what the planet could do without warning. The telegraph did not save the villages already lost. It could not stop the sea. It could not warn the ships trapped in ash darkness before the worst moments arrived. But it changed what happened after. It meant the disaster could be followed, discussed, measured, and feared across continents while its effects were still unfolding. Krakatoa became one of the first great natural catastrophes of the modern information age, a planetary event carried by both the atmosphere and the cable. Then science began to answer. In Britain, the Royal Society formed a special committee to gather evidence from around the world. The task was enormous. No single witness could understand Krakatoa. No single instrument could contain it. The event had scattered itself across oceans, skies, ship logs, barometers, tide gauges, letters, newspapers, and human memory. So the committee collected everything it could: accounts from sailors, reports of falling ash and floating pumice, records of strange pressure waves, descriptions of sea level disturbances, measurements from observatories, stories of sulfur in the air, violent sunsets, distant detonations, and nights that glowed with unnatural colour. Piece by piece, the catastrophe became a record. This was one of Krakatoa's deepest legacies. The eruption forced science to think globally because the volcano itself had behaved globally. Its sound had crossed oceans. Its pressure wave had circled the Earth. Its aerosols had altered skies thousands of miles away. Its tsunami had been measured far beyond Indonesia. The old idea of a disaster as something local was no longer enough. In 1888, the Royal Society's Krakatoa Committee published a major report on the eruption and its aftermath. It was not simply a memorial to destruction. It was an attempt to understand the Earth as a connected system. A volcano was no longer just a mountain. It was a force that could enter the sea, the air, the climate, the press, and the laboratories of distant nations. The report helped establish ways of studying volcanic events that would shape future geology, meteorology, acoustics, ocean science, and atmospheric research. It showed that scattered observations, gathered from many countries, could reveal the shape of a single planetary event. The tragedy had created data, but that sentence should never feel clean, because the data came from a morning of terror, from destroyed coastlines, from ships moving through darkness, from people trying to describe skies they did not understand, from survivors standing on shores where entire communities had been taken away. Science learned from Krakatoa because the world had suffered through Krakatoa. That is the burden hidden inside many breakthroughs. Knowledge often arrives after loss has already done its work, and Krakatoa changed what humanity believed it could know. It proved that an eruption in the tropics could be measured in Europe, that a pressure wave could return from the far side of the Earth, that dust above one ruined island could transform sunsets across continents, that the planet's systems were not separate. They were linked. The telegraph carried the news. The instruments carried the evidence. The Royal Society carried the investigation. And through all of them, Krakatoa became more than a destroyed island in a narrow strait. It became a warning written into the foundations of modern Earth science. The world had heard the volcano. Now it had to learn how to listen. After Krakatoa, the work of counting the damage began. It was slow work, not the kind that belongs to a single morning, but the kind that stretches across weeks, maps, reports, coastlines, and graves. Colonial officials moved along the shores of Java and Sumatra, trying to document what the sea had taken. Village names were written down. Harbours were inspected. Survivors were counted. The shape of loss was forced into columns, lists, and official language. But no report could fully contain it. The disaster had not only killed people, it had changed places. It had moved ships where ships did not belong. It had erased familiar landmarks. It had made the old shoreline feel unreliable. Communities that had once lived close to the water now faced a terrible knowledge. The sea could return higher than memory, higher than tradition, higher than anything their villages had been built to survive. So some settlements were rebuilt on higher ground. This was not simply construction. It was memory turned into geography. Every road moved inland. Every house raised away from the shore. Every new settlement placed above the old danger line carried the same message. People could rebuild, but they could not pretend the morning had not happened. The Sunda Strait itself also had to be understood again. Navigation charts no longer matched reality. Krakatoa had changed the seabed. It had altered the islands. It had left behind remnants where a larger volcanic landscape once stood. For sailors, map makers, and colonial authorities, the strait had become a new place with an old name. The volcano had redrawn the world, but on the stripped remains of Krakatoa, another story began quietly. At first, there was almost nothing. No forest canopy, no birdsong in the trees, no familiar green slopes rising above blue water. The island remnants were bare, burned, and covered in ash and volcanic debris. To human eyes, they looked finished, a place emptied of life. And yet, in the years after the eruption, scientists began to notice what destruction had left behind. Krakatoa had become something rare, a natural laboratory, a landscape where life could be watched as it returned almost from zero. The first signs were small. Plants began to appear. Ferns and grasses found places to hold. Seeds arrived by wind, by water, and by birds moving across the strait. Insects followed. Then more plants. Then birds. Slowly, what had looked sterile began to organize itself into an ecosystem again. There was no single dramatic moment when Krakatoa became alive. Life returned the way it often does, patiently, unevenly, almost invisibly at first. A root in ash, a seed in a crack, a bird crossing open water, an insect hidden in driftwood. Each arrival was small enough to miss. Together, they became one of the most important stories in the history of ecological recovery. Scientists came to study the process because Krakatoa offered a question that was both simple and profound. How does life begin again where everything has been destroyed? The island did not answer quickly. It answered through decades, through field notes, specimen lists, plant surveys, bird observations, and returning expeditions. The recovery of Krakatoa helped shape the study of how species colonize isolated land, how ecosystems assemble, and how fragile beginnings become living communities. This was not a reversal of the tragedy. Nothing could reverse that. The villages lost along Java and Sumatra did not return because a fern grew on ash. The dead were not restored because birds found the island again. the wound of 1883 remained. But Krakatoa revealed another truth, one that did not erase the grief but existed beside it. The earth destroys, and the earth begins again. On the same island where a mountain had torn itself apart, life slowly rebuilt without ceremony, without witnesses at first, without needing human permission. The green returned not as a victory over disaster, but as a reminder that destruction is not always the final state of a landscape. Krakatoa had become two things at once, a grave of geological violence and a classroom for the science of renewal. For the people who survived, rebuilding meant carrying loss into the future. For scientists, studying the island meant watching the future appear from ash. In both cases, Krakatoa refused to remain only a story of ending. The disaster had changed the coast. It had changed the charts. It had changed science, and now quietly, it was changing the meaning of recovery itself. For decades after 1883, the old crater lay beneath the sea. Krakatoa had become a name of destruction, a warning carried by science, memory, and maps. The island that had once stood in the Sunda Strait was gone, reduced to remnants around a submerged wound in the earth. But the volcano was not finished. It had only changed form. In 1927, nearly half a century after the catastrophe, the sea above the old caldera began to stir again. Steam rose from the water. Small eruptions broke the surface. Ash and new volcanic material gathered where the old island had collapsed. Slowly, a new island began to rise. It was given a name that carried both grief and continuity. Anak Krakatoa, the child of Krakatoa. The name was simple, but the meaning was immense. It suggested that 1883 had not been a final ending. The same deep magmatic system that had destroyed the old volcano was still alive beneath the strait, still building, still pushing upward through the ocean floor. Anak Krakatoa grew over the decades, layer by layer, eruption by eruption. Each new deposit added to its cone. Each phase of activity reminded scientists that volcanic islands are not permanent monuments. They are processes. They are moments in a much longer geological story. To human eyes, land feels stable. A coastline feels fixed. An island feels like a thing that belongs to the map. But Krakatoa had already proved that maps are only temporary agreements with the earth. What rises can collapse. What disappears can return. What seems finished can begin again under another name. Volcanologists came to watch Anak Krakatoa closely. Monitoring stations, field surveys, satellite observations, and repeated studies turned the young island into a living classroom. Here, scientists could study not only the memory of a past catastrophe, but the behavior of a volcano still writing its future. And the future remained dangerous. In December 2018, Anak Krakatoa reminded the world that the story of 1883 had never truly closed. Part of the volcano collapsed during an eruptive phase, displacing water in the Sunda Strait and generating another tsunami along nearby coasts. Again, the danger did not arrive as a distant theory. It arrived as water. Again, communities facing the strait learned that a volcanic island can threaten not only with ash and fire, but with the sudden movement of the sea. The 2018 tsunami was smaller than the catastrophe of 1883, but its message was painfully familiar. The child of Krakatoa carried the same inheritance as its parent. Creation and destruction were still bound together. This is why Krakatoa remains more than a historical disaster. It marks a turning point in the relationship between human civilization and the natural sciences. Before Krakatoa, the global reach of volcanic eruptions could be imagined. After Krakatoa, it could be measured. The atmosphere was shown to be shared. The oceans were shown to be connected. A single eruption in the tropics could darken skies, move barometers, alter sunsets, disturb climate, reshape coastlines, and send data across the world. It could destroy a local landscape and still leave evidence on every continent. Krakatoa forced humanity to think at planetary scale. The telegraph cables that carried the news in 1883 were the ancestors of every modern information network that followed. Today, satellites watch volcanoes from orbit. Seismometers listen beneath the ground. Tide gauges measure the movement of the sea. Sensors, models, and warning systems search for signals that earlier generations could only recognize after it was too late. But technology has not made the planet harmless. It has only made the warning more visible, and that is the burden Krakatoa leaves behind. The disaster taught science to listen across oceans and continents. It showed that the Earth speaks through pressure, ash, light, water, temperature, and sound. It showed that no coastline, no city, and no generation lives outside the systems that connect the planet. In 1883, the roar of Krakatoa circled the Earth again and again. In a sense, it is still circling. Not as sound anymore, but as knowledge, as a warning, as a memory written into geology, climate science, oceanography, ecology, and disaster monitoring. The island destroyed itself in one morning, but it gave the world a lesson that still has not ended. Beneath the Sunda Strait, the forces that built Krakatoa remain alive. Above them, Anak Krakatoa continues to rise, erode, erupt, and change. The child of the old volcano stands as a reminder that the Earth is not a finished surface beneath our feet. It is a living system, beautiful, unstable, and far more powerful than the world is ever ready to believe.